Yes. As we have seen in our previous session, we are dealing with the bivariate distributions. Bivariate distribution, that as I told you in our previous session, that in the introduction to bivariate distribution, that is, it is nothing but a distribution containing two random variables simultaneously, that is x and y. That's why the word by suggests, that is the why word by suggests. By stands for two. So in this cases we are dealing with two random variables. So we have learned that how the distribution, how we are going to deal with the probability distribution for the case of two random variables, taking them simultaneously. Now here, before moving on to the further part of bivariate distribution, the two terminologies are there that I need to clear it out at first, and then we can move on to the further part of bivariate distribution. One is the correlation, and another is the word regression. Correlation and regression. So what does this correlation word stands for two random variables? For the case of two random variables, it gives us, it is nothing but a measure. It is a measure that gives us the association between the two random variables x and y. Rather, you can say it is the strength of association. It gives us the strength of association between the two random variables x and y. That how much they are associated with each other, how related with each other. That thing gives, that measure is nothing but that gives us by the measure which is known as correlation. Okay, that the word correlation suggests this much only. Now, what does then regression stands for? The basic idea behind the regression is prediction of one variable, when the other one is known to us. When the other variable is known. Prediction of one variable when the other variable is known. That is, say, we know the values of x variable and we have a relation between x and y as y equals to ax plus b, where a and b are the constant quantities that are also given. So when x is known, we can predict the value of y. So this is nothing but the regression. Prediction of one variable when the other variable values are known to us. Okay, and the correlation gives us the strength of association between the variables x and y. It may happen the two sets of variable either related or unrelated, not related to each other. So if they are related, then there should be the strength of association, how much relation is there between them, whether they are exactly coincide with each other or whatever is there. So that strength, that amount of association, that strength of association, degree of association between them is given to us by the word correlation. Okay, it may happen that the two variables are not at all related to each other. Say, for example, if I take the practical life examples, say I'm taking random variable x is denoting the amount of rainfall in an area. Amount of rainfall, and y denoting the amount of crop yield. Amount of crop yield in that area. So we know that they are related to each other. There is an association between the variables x and y. But if I take the random variables x to be the height of the student, in a class, and y is denoting its IQ level, IQ of student. So all we know that from our general sense that height does not depend on IQ. They are not at all related with each other. So correlation between them is zero, nothing. They are, we can say them, they are uncorrelated. Uncorrelated. So in this case, the correlation between them will be 0, but in this case, we will get a strength. So how much they are related, what is the degree of association, that we can find out utilizing the measure of correlation. So this is the two words which we are having in the case of bivariate data or the bivariate distribution. That is, one is correlation, another one is regression. So let's come to the notes where we are going further for the correlation for the bivariate distribution. So let us move on. See. Yes. The very first thing, as I told you, the correlation. This covariance words from the correlation only. That is, the covariance between the two random variables means nothing but we are finding the related, how much they are related to each other. And there is a specific formula to obtain the covariance. Covariance of xy equals to expectation. As you can see from here, covariance of xy, let me go to on. Covariance of xy is expectation of x minus x bar into y minus y bar, where x bar and y bar are the means of the random variables x and y respectively. And in the modified form, we can write the covariance as covariance of xy equals to expectation of xy minus exxy. The proof is given over there. We can go through that. We can go through the proof as well, that covariance of xy by definition, it will be expectation of x minus x bar, y minus y bar. Then comes, if I remove the bracket, then we will be having xy plus x bar y bar minus xy bar minus x bar y. And taking throughout expectation and simplifying, we will get it as expectation of xy minus exy. So this is one of the modified form of covariance. Next comes, as I told you, that if x and y are independent random variables, then there is no association between them. So covariance between them is 0, and the formula also gives us the same thing. Now come to the main measure, important measure of correlation, which is known as the correlation coefficient. This have a specific formula, that is, it is denoted by rho xy. And the formula by which we can evaluate the correlation coefficient, that is covariance of xy divided by sigma x, sigma y, where sigma x and sigma y are the standard deviations for the random variables x and y. Now we can take a particular problem. Let us see what the problem is there. That there is a bivariate distribution given to us. We need to find out the covariance and correlation coefficient between the variables for which the bivariate distribution is given to us in the particular problem. So let us go to the whiteboard where we are going to do this particular problem. Let me go. Let me write the bivariate distribution at first. That is, values of the random variables y, and this is y, and x are given to us as values of first value is 0, 1, 2, and 0, 1. Another probabilities are given to us 0.1, 0.4, 0.1, 0.2, 0.2, 0. All right, the sum of the probabilities for x random variable, it is 0.6, 0.4, 0.3, 0.6, and 0.1. And this total is equals to 1. So we need to find out the covariance at first between x and y. All we know that the formula for covariance is the modified form. If I take expectation of xy minus expectation of x into expectation of y. So let us evaluate one by one. First, I am going to take on expectation of xy. By formula, since it is a case of discrete random variables, so summation over I j xi yj pij. So one by one, we will put on 3 values of y's are there and 2 values of x are there. So j varying from 1 to 3 and I varying from 1 to 2. So first we will take the summation over j. So it will be j equals to 1. So xi y1 pi1 plus xi y2 pi2 plus xi y3 pi3. Now we can take y1 outside, since we need to take summation over x, summation over I. So y1 into summation over I, that is I varying for 1 to 2, two values. So x1 p11 plus x2 p12, sorry, p21 plus only two are there, plus y2 into x1 p12 plus x2 p22, then y3 into x1 p13 plus x2 p23. So now just putting on the values, y1 means it is 0, so this total part is 0, plus y2 is 1 into x1 is 0 into p12 plus x2 is 1, p22 is 0.2 plus y3 is 2, x1 is again 0 into p13 plus x2 means 1 into p23, that is 0. So this part also becomes 0. So we are left with only this part, that is equals to 0.2. So expectation of xy becomes 0.2. Now let's come to expectation of x. What it will be? This is summation over I xi pxi. So it will be summation over x, I varying from 1 and 2. So I will take it as x1 px1 plus x2 px2. So x1 means 0. So this part is 0. Then 1 into px2 is 0.4. 0.4, that is equals to 0.4. Similarly, expectation of y, summation over j, yj p yj. So it will be y1 is 0. So y2 means 1 into py2, 0.6 plus y3 means 2 into 0.1. So it will be 0.8. So we have covariance between xy equals to 0.2 minus expectation of x is 0.4, y is 0.8. So the results becomes, it will be 0.12. So in this way we have found the covariance. Now we can move on for the correlation coefficient. For correlation coefficient, what else is required? That is sigma x and sigma y. Sigma x is what? Sigma x, all we know that sigma x square is expectation of x square minus expectation of x whole square. So expectation of x we have already found, so whole square we can do it. We need to find expectation of x square only. So by finding it, we will get sigma x. Similarly, we will be getting sigma y, and the correlation coefficient rho xy will be then covariance of xy divided by sigma x into sigma y. So in this way, we can find the correlation coefficient as well as the covariance for the particular problem.